Hello. In this presentation, we will analyze the different problems that had to be resolved in order to carry out the construction work on an elderly people's home, Los Rosales in Zaragoza, in order to obtain the passive house certificate. I'll focus on 3 of the 5 main principles: airtightness, thermal bridges, etc. The following table summarizes the most important values of the project. Just for your information, the last time I spoke with the certifier, with Luis, they were pending the performance of the blower door test in the entire building, and all they had to do was to receive a fire door. So let's begin by looking at installation. The owners had 3 priorities. They wanted the building to be highly efficient in energy terms, with sustainability criteria in the use of materials. They wanted construction to be quick, and they wanted to use a construction system in which there was an excellent relationship between total thickness and thermoacoustic insulation. This is a basic project that was designed, reviewed, and it was defined in the years before the crisis. Therefore, the useful surface area had to be maintained. It couldn't be reduced. With all this in mind, we decided to choose the Sate Knauf insulation system for the exterior, for thermal insulation, comprising a self-supporting metal structure, standard plasterboard, and also exterior cladding, Knauf aqua panel, and 2 insulation levels, FK, and also another with 100 millimeters for interior cladding. The Knauf aqua panel system was chosen because it had a document which facilitated execution of this work. The thermal transmittance was 0.17, very low, and 87%. The total facade thickness and total insulation thickness ratio. In terms of thermal bridges, the 3 most critical ones were those executed by specific mechanical fixing and also the flooring edging. We decided to adopt this approach, as you can see in the diagram, because it reduced the thermal bridge substantially, and the overall thermal bridge generated by these anchoring points meant that the effective insulation was 150 millimeters instead of 200. In terms of the flooring edges, we decided not to insulate these edgings because the thermal bridge generated was very low and balanced thanks to the panel. It was a panel which was not very thick, 15 millimeters, and thermal conductivity, which was not bad either. So we decided not to insulate, and it didn't entail further problems for obtainment of the certificate. In terms of airtightness, this was one of the major challenges because we decided to achieve this using plasterboard, the first plasterboard of the cladding, and we decided to tape the joints between, or meeting points between, the pillars and the partitions or walls. This entailed challenges during the execution of the work and the useful life of the building. What were these challenges, or these premises? Well, the first was that no holes could be made in the facade cladding panels, because this would undermine the airtightness and useful life of the building, nor could any switches or plugs be opened in the walls. And 2 tapes were actually applied, one on the self-supporting metallic structure in the first panel, and the second in the exact location of the screws, which would secure the second panel to the first, to avoid leaks or filtration through these holes. Other problems were that the tapes did not guarantee airtightness at the meeting points between the flooring and the vertical partitions, because the rugosity of the concrete made this difficult. So we opted for the liquid membrane solution, and then there was no problem in passing the blower door test by sectors. The final points taken into account are not in the passive house standard on overheating. It's a scenario that we're going to have to become accustomed more and more in the future. Therefore, different actions were performed. On the west facade, the percentage of windows was reduced. On the southern facade, which was more exposed, vertical awnings were installed. And Underfloor heating and cooling was also provided and installed. And depending on the sensitivity of the residents in hotter areas, the residents, for example, that were less sensitive to heat would be housed. Well, that's just a quick overview of the critical points that had to be resolved. I hope the information's been useful. And the co-authors of this short study were Luis Miguel Soler Carbo, who is the consultant in charge of the work, Cinzia Maggio, my colleague in Knauf Insulation, and myself, Felix Garcia Primi. I'm the technical manager of Knauf Insulation. Thank you and see you soon.